Hi, I'm your professor, Dr. English Dowdell, and welcome to another lecture of our Mobile App Fundamentals course. For this lecture, we're going to be exploring the essential aspects of mobile design, which is app architecture and user flow. Now, when we design mobile apps, we're not just choosing colors and fonts. We also need to understand like how our design fits into the underlying technical structure of an app. A well-designed or well-structured app is going to ensure a very smooth user experience, efficient performance, and an easy collaboration between like the designers and the developers. So in this lecture, we're going to briefly just kind of go over some core components of mobile app architecture. This may include like navigation and UI elements and data flow. We're also going to analyze how app architecture supports user interaction and enhances functionality. We'll also look at how navigation flow diagrams help demonstrate the relationship between like the different screens and the app structure. And then we'll talk about how you would collaborate with developers, by presenting different designs that align with the technical considerations and the app architecture principles. So let's start off by understanding what mobile app architecture means and why it's crucial. Now, mobile app architecture is a comprehensive plan that outlines an application structure, its behavior, its interactions. It serves as a blueprint, kind of guiding the developers in building scalable, maintainable, and of course, efficient applications. Now, just as an architect designs the blueprint, say for a building, software architects design the architecture for mobile apps, ensuring a solid foundation and a cohesive structure. Now, why is app architecture important? Well, one, it ensures seamless user experience. A structured architecture means users can easily navigate the app, without being confused. Another important reason is it improves performance. So a well-planned app structure, it's going to reduce like lags and crashes and unnecessary background processes. And then it's going to simplify collaboration with the developers. Designers need to understand like how their UI decisions are going to really impact as far as back-end functionality. They can't just design within a silo. They have to understand, what's going on in that back end and how, whatever they're designing is going to be a factor and affect that. And then it also allows for scalability. A well-designed architecture, it's going to make it a lot easier to add different new features if you need to in the future. And we know mobile apps constantly get updated, so you want to be able to make it so that it's easy to add these new features in the future. You don't have to start from scratch, with your design. Now, mobile app architecture is comprised of several essential components and patterns that work together seamlessly. So let's explore some of these components. So first you have your presentation layer. This is like your user interface. So the presentation layer is responsible for like what the user actually sees and interacts with. UI components such as buttons, text fields, menus, and forms, these are all part of this layer. The navigation structure, like the hierarchical, the tab-based, or the gesture-based, is also part of this layer because it dictates how users will move through the app. So examples of this maybe like in social media apps, the news feed, the profile page, the post creation screens, these would all fall under the presentation layer. So for instance, if we had like a weather app, Okay, the main screen that shows the current temperature, the forecast, and the search bar, these would all be part of the presentation layer. Okay, then you have what's called the business logic layer. And this is the layer that handles like the core functionality and the business rules of the application. So it would include components like services, managers, repositories, things like that. Um, Examples would be like in an e-commerce app, the shopping cart management, maybe the order processing, and the payment handling. These would all fall under the business logic layer. Now, while navigation, again, is still part of that UI, it also interacts with the business logic layer to trigger actions based upon the user input. So, for instance, when a user selects a new location in our weather app we talked about, this action is processed in the business logic layer, which then retrieves and formats the necessary data before sending it back to be viewed in the presentation layer. So, maybe like clicking a city, in the city selection screen is going to trigger a function in the business logic layer to fetch and display the correct forecast. Then you have what's called the data layer, and this is like data handling and storage. Now, this layer is responsible for managing data persistence and retrieval. And it includes components like databases, API clients, data models. So, maybe in like a note-taking app, the database, that is used to store the notes, and maybe the cloud synchronization logic would fall under the data layer. Um, so again, like I said, think about it's responsible for storing and retrieving and managing the data. Now, data in mobile apps, they can be stored locally, like you could have like SQLite or Room for Android, or you could actually store the data remotely, like through APIs, or maybe if you had like some kind of cloud database. And so this business, the when it comes to as far as the data layer, the business logic layer is going to interact with the data layer in order to be able to fetch, that data or to be able to update the data. So again, going back to our example of our weather app, say the weather app is going to retrieve the temperature data maybe from an API, and then format it through the business logic layer before displaying it in the presentation layer. So that's how it all works together. So, if we think about how it all connects, think about like if a user taps on a button, okay, that's going to be on the presentation layer, and then the app is going to process whatever that request is of the button. That's going to be done on the business logic layer. And then the app is going to say maybe fetch the data from a database or an API. That's going to be that data layer, and then the app is going to update the UIs, with whatever the retrieved data is. We return back to the presentation layer. So that's how all of these different layers kind of work together when it comes to as far as a mobile app architecture. Now, user flow in a mobile app design represents the path a user takes to complete a specific goal within an app. Now, this path includes like every step from the entry point to the completion of whatever the task is. Now, why is user flow essential in mobile app design? Well, one, it enhances usability by ensuring logical navigation through the app. It also improves user engagement by making the interactions a little bit more intuitive. And then it identifies different pain points, to refine like the mobile app functionality. We try to find like target points that we need to improve. And then we continuously update it, in order to be able to improve the quality and the user experience. Now, user flow in UX design and in mobile design, mobile UX design is the user's path to finish, say, a specific purpose. So it includes, again, each step from the start point to the end point. Now, user flow can help stakeholders to understand users better, and how, say, a real person's going to be interacting with, whatever it is that's being designed. So, some of the steps for creating a mobile app user flow is one, research the user. You want to analyze the problem. What's the purpose of the users? What are they trying to do? What services do they want? So on and so forth. And then you want to list the purpose and the goals that you want to achieve with this app. Then you want to list the possible steps, in the application, or the mobile app that you're working on. And then you'll create that user flow to get them again from point A to point Z. And then what you want to do is you want to constantly review that and update it to be able to streamline it, so that you're being able to provide the best possible path, user's path, to help that user to complete whatever the task that it is that they're trying to do. Now, there's a lot of different tools out there that will help as far as creating like user flows. These are just a few. You could actually create a user flow, using Microsoft Word. You can do it, on a manual piece of paper, whatever the case is. The thing is, again, what you want to do is you want to capture every step from the entry point to whatever it is that the user's trying to complete, whatever the task is that they're trying to complete. Now, there are a few types of diagrams that are used to be able to show um, the user flow within mobile UX design. There's the task flows, and this is just like a one path flow chart, when you're trying to accomplish like one specific mission. Then there's what they call the wire flow, which is a little bit more complicated. It's created after you create the prototype, or the wireframe. So it actually shows like the screenshots and things like that, or the mock-ups, or the wireframes of how a user would get from point A to point B. And then there's user flows. So let's just kind of compare task flows with user flows. So for a task flow, this is a visualization of specific steps, that are undertaken to accomplish a goal in your product. And task flows are typically linear. um, they generally represent like a direction, a very predictable, ideal way a user would accomplish a goal in the product. They're sequential, so the task flows are a series of steps that take a user from the beginning to the end of the goal. And then it's very simple. Task flows tend to be kind of straightforward, and they don't really branch out with, any kind of options or decision points. They're useful for like ensuring that you're designing again sequentially and thoroughly. They serve a purpose. They picture, it's like a picture of an ideal user choice, like a happy path is what we used to call them. But task flows, they're going to have their limitations. They're static and they reflect the thought process of the individual that's creating them. And the task flows, they assume that the users are all going to behave the same way. Now, while these are serious drawbacks, task flows do serve as necessary, precursors for designing more complex user flows. So like we see here in this example, this task flow as we wake up, we make the bed, we get dressed, we make breakfast, we drive to work. Very straightforward, happy path. Everything works out, fine. Okay, so that's a task flow. Um, but like I said, task flows, they focus on steps, to achieve again one goal. While user flows, they focus on your target audience's interaction. with a product. So user flows, they emphasize that all users might not perform tasks the same, and they may travel in different paths. And they're attached to a specific maybe persona. You may have different like scenarios that start in different places. So, task flows, they reflect again the target audience's real decision points and actions. Again, users, they're going to have different ways of interacting with your mobile app. And each user's specific needs, their wants, and their choices can be illustrated in this user flow. And then it includes like multiple ways to enter and exit the flow. User flows, they're going to document the way a user begins and ends their engagement, with the product. And then of course they have a little bit more complexity, and nuance. These user flows, they account for and honor like user choices. They help designers kind of spot and eliminate like if there's any kind of dead ends or anything like that, where users might get lost in the mobile app design. Now, parts of the user flow would be like your entry point, by which, a user is going to be accessing, the mobile app. So are they going to be getting there through like a Google search, or are they going to be clicking on an ad? Are they going to be, clicking a link or something like that? Um, they stick to steps needed for the user to achieve their goal, so they only deal with the steps to completion. And then there's the other point is the final interaction. And this is like the final screen that the user is going to see, say, when they accomplish their desired task. So if we look at the comparison to the task flow, the user flow, the alarm clock rings, then we have a decision point. Are we ready to wake up? I mean, ideally, we would wake up according to the task flow, wake up, make the bed, get dressed, make breakfast, drive to work. But here we understand that users may not be ready to wake up. So we have a decision point. Are they ready to wake up? No. Then sleep in, and then, the alarm clock rings again. Now, if they're ready to wake up, then we go yes. And then we say, make the bed, get dressed. And then we say, are you hungry? Are they actually hungry? We, in an ideal world, we're saying we're going to make breakfast and eat, but we're saying, are they hungry? If they're hungry, then we'll make breakfast. But if they're not hungry, then we're just going to drive to work. And then the workday begins. So again, you've got those decisions. It's not such a happy path, and it's more reflected on like a real world, persona or something like that. Now, you can make your mobile user flows, like I said, you can use PowerPoint, you can even draw them out on paper. They don't really need to be very complicated. You don't actually have to have for a basic user flow, you don't have to have, like I said, the screenshots and things like that. You can just show as far as like the different actions. So these are the elements that we would be using like if we were to do a user flow for our mobile app. So we'd use like a rectangle, which would represent like a page or say a display screen within our mobile app. We would use lines with arrows that would basically tie everything together, and determine like the flow, through like whatever the user flow is. And then circles depict like different actions. They represent like a process, a task, or an operation. And these are usually like verbs. And then diamonds are our decisions. They always are going to ask a question. They're going to show a decision needs to be made, and then you'll have like a yes or a no arrow, like you saw, in the previous slide, that will extend from each. Now, there's no set of rules or guidelines on how to create a user flow. If you're consistent with your shapes, whoever is looking at your user flow can be able to follow and understand the flow. You want to make your labels meaningful. Use a title that describes exactly like what the user flow represents. Avoid also using all capital letters. Use colors, as a coding system. And then use a legend key, for those that maybe aren't used to reading, these type of diagrams. Now, last, I want to kind of tie everything together. So, I want to talk about how user flows are going to impact, the app architecture. So, your app's structure should make navigation intuitive and efficient. A well-designed user flow can influence app architecture, in different ways. One, user flows kind of help determine like whether an app, is going to use like a specific navigation structure. So are they going to be using a hierarchical structure? They're going to be using a tab-based structure, or a gesture based navigation. So understanding how a user is going to flow through your app is going to help you to pick the appropriate navigation structure. The second thing is that it helps with screen organization. So if a user flow shows complex decision making, then the app architecture must support conditional paths. That is like different screens based on the different user choices. Okay. It also is going to help with data handling. So if a user flow requires like real-time data updates, then the app architecture must include efficient back-end communication, like, to different databases or to maybe making API calls. And then it's also going to help with performance consideration. So if a user flow involves frequent navigation between different screens, then the architecture must optimize memory management and caching. So if you're going to be going from screen to screen, then you've got to use that memory management, or like I said, cache different data, so that you're not constantly pulling data, from the database every time you go to a new screen. Okay. So an example might be like a to-do list. So if we look at the user opens the app, and then they say view the task list. They click on a task. They maybe edit that task, and then they save the changes. So the app architecture has to support that. So one, maybe for the navigation, we may deem the way that we're going to be going through the app is that a tab based is going to make it a lot easier for switching. You know, um, we have to support as far as, like I said, being able to store the different information from the task. So, we look at the data layer. So we might want to use like maybe local storage for that, with maybe some optional like cloud syncing or something like that. And then we'll have to look at, because of the fact that maybe we're integrating with an API or something, so we have to look at like the back end communication, maybe some API calls for cloud syncing. Again, how are we storing that information? So in this case, user flow is going to dictate like what kind of screens, what kind of storage and what kind of APIs are going to be needed. And that's going to influence how the app is going to be built technically. Now, by considering both user flow and architecture, your team can ensure that the app is going to be not only user friendly, but also technically sound and provide a good user experience.